All right, in this video, we're going to go over an example of solving a proportion that requires factoring. You know that your proportion is going to involve factoring when you have two linear binomials that are diagonally across from each other in the proportion. So if we take a look at this, we can think about all the properties of proportions, but none of them will really simplify this equation. So its reciprocal form won't help. It won't really help if we exchange the means or the extremes. So we're just going to go ahead and cross multiply. So when we cross multiply, we're going to multiply diagonally. So I'm going to do 8 times 3. And my other cross product is going to be the product of the quantity x plus 3 times x minus 2. And remember, our cross products are always equal in a proportion. So when we multiply 8 times 3, that's the easy part. That's 24. The harder part is x plus 3 times x plus 2. This is when you need to go back to what you learned in Algebra 1, how to multiply two binomials. And you probably either learn the FOIL method, which is when you multiply the first, then the outer, then the inner, then the last, and add those up. Or you learned maybe using an area model. I show my students the area model. You're welcome to use whichever method you prefer. If you use the area model, you're going to assign the operation to the second term. So x plus 3, I'm just going to think of that as a positive 3, and x minus 2, I'm going to think of that as just being a negative 2. Now, if you're using the FOIL method, you'll see we get the exact same values. So x times x is x squared. X times negative 2, which would be like your outside if you're foiling, is negative 2x. X times 3 is going to be 3x, and 3 times negative 2 is negative 6. So I just multiply the rows and columns to fill out the table. Then we'll usually have some middle terms that we can reduce. So x squared minus 2x plus 3x minus 6. I know that negative 2x and positive 3x, I can combine those to get just positive 1x. Okay, so going back to our proportion, when we multiply the cross product of x plus 3 times x minus 2 is x squared plus x minus 6. All right, so now we have a quadratic trinomial, and it's set equal to 24. And if we were to factor that, we would just get what we started with. It would not help us right now to factor, but if you think about what this looks like, we know that this is going to be a parabola, and that it's going to, it's going to touch the x-axis in two different places. So what would be helpful is that if instead of having this set equal to 24, it would help us to have this set equal to 0 so that we can solve by factoring. So we're going to now subtract 24 from both sides of this equation. Oops. And again, the reason we're doing this is we want this set equal to 0 so that we'll be able to find the roots algebraically. So x squared plus x, the only number affected by subtracting 24 is this negative 6. So negative 6 minus 24, that's really like combining two negatives. We're going to get negative 30. Okay, so now we're going to factor this expression. All right, so we're at a point where we can factor, and we're going to consider this in standard form. So remember, when we talk about the standard form of a quadratic, a is the coefficient of x squared, b is the coefficient of x, and c is our constant term. So when I look at this, I'm going to find the product of a times c, and in this case, a is 1 and c is negative 30. So 1 times negative 30 is negative 30. Then I'm going to put b in the bottom of this x. So the coefficient of x is just 1. And now I'm going to look for two numbers or two factors that multiply to negative 30 but have a sum of positive 1. And if I think about it, if it's two numbers that multiply to negative 30, I know one is a positive and one is a negative since their product is negative. So I really want to think about what factors of 30 have a difference of 1. And my brain goes straight to 6 and 5. So I can use positive 6 and negative 5 because 6 times negative 5 is negative 30. Positive 6 times negative 5 is plus negative 5, excuse me, is positive 1. Okay, so this is the easiest type of factoring because our a value was 1. The coefficient of x squared is 1. So there's a shortcut. I don't have to go straight to factoring by grouping. My shortcut is that I can write my factored form of this expression as x plus 6 and x minus 5. I can take the number straight from here. I don't have to go into the grouping scenario. So now this is set equal to 0. So now I can use the zero product property to say that if the product of these two binomials equals 0, I could set each binomial equal to 0 to find the zeros of the quadratic. So x plus 6 equals 0, subtract 6 from both sides, x equals negative 6. Then we'll do the same with x minus 5. X minus 5 equals 0, add 5 to both sides, x equals positive 5. So the two solutions that would satisfy this proportion, x could equal negative 6 and x could equal positive 5. And now if you want to verify this on your graphing calculator, that's a really good idea. Go into y equals, delete anything that's in there, type in the quadratic, type it in standard form. So when we got to x squared plus x minus 30, let's just type that in. So x squared plus x minus 30. You might have to double check your window. I think mine will be okay. And we're looking for the two places where the graph crosses the x-axis. And if you want to find those in the calculator, you can go to second trace. That brings up the calculate menu. We call those zeros. So we go to 2 for 0. And it's going to ask you for a left bound, a right bound, and then a guess. So you scroll all the way left of the 0, hit enter, scroll to the right, hit enter, go back and guess, hit enter, and our calculator tells us that we have a 0 where x equals negative 6. You can see that's one of our solutions. If we do that process again, so second trace, number 2 for 0, hold down that right arrow so that it scrolls all the way to the right. Okay, so we're left of the bound, we're left of the intersection, right, and then guess. Our other 0 is at 5.